Hello everyone, this is Kranti Kumar from St. Peter's Engineering. Today my topic is solid mechanics. Mechanics is a science of branch which deals with the effects of force on bodies. That means many bodies are in rest. These are in rest. To learn about this rest position or in motion, we learn this mechanics. Is a science which deals with effects of force. These are the force we are giving to one body. It also considers with behavior of bodies act upon the forces. There are different forces act upon these. This comes under solid mechanics. What is a solid mechanics? The branch of science which deals with the state of rest of motion are termed as solid mechanics. So these are the different types of models in mechanics of solids. A rigid body. This is a rigid body. If I hit this body due to some force, it may break. This rigid body is defined as a body which distance between the 2 points never be changed and force applications. This is called a rigid body. Next is a deformable bodies. A body is defined as a body in which a distance between 2 points change under the action of some forces. If you apply this example, an athlete is running from a distance between 2 points. When he apply a pressure on the ground, he will rise up and fall here. This is a form of deformable body. It will deform in some places, which the distance between 2 points, this is the first point and this is the second point, changes under the action of some forces with applied on it. What we are doing, we are applying some force to this stick for a long jump. When it is applying on 2 points, first and here, then we call it as a deformable bodies. Similarly, the continuous deformable bodies. A substance which deform continuously with external force act upon it. Take an example of vessel. In vessel we have some water. If shake some water content, it has continuous deformations. Similarly, in the oceans and rivers, there is a deformable bodies. Next, what is the classification of mechanics? As already explained, mechanics is a branch which deals with statics and dynamics. Statics, which are called as rest position. Similarly, dynamic is called as motion. Statics, which affects on the bodies that are rest, is called statics. In this unit, I am going to explain different types of statics. Next, what is a solid mechanics? Engineering mechanics are broadly classified into two types, as I explained, statics and dynamics. If you observe this example, he is in the standard position, rest position. Rest is a rest position and he is in the motion. He is in the motion. While it is in moving direction, we call it as dynamics. And when it is in a rest position, we call it as statics. Next, what is the main content of the statics? The branch of science or a mechanics which deals with effects of forces which are in rest is statics. Load on the roof acting on a pillar. A man is standing in the books on a particular place is called statics. If same man is moving, it is called dynamics. Which are in the motions is called dynamics. Similarly, these are the effects. Next, we already heard what is a force. Force is a tendency or an agency which changes from the state of body which is in the rest or uniform motion. If you observe this diagram, a man is pushing the load and he is pulling the load is called a force. What we are doing, we are applying some force here. We are applying some force here and we are taking the force from here. This is an example of force. That is an agency which changes or tends to changes from state of rest of uniform motion is called force. There are many examples of forces, like where ball is throwing from the ground, we are catching a ball and hitting the wall. There are many forces applicable for this force. When we have to go from one place to other place, we need some force. Similarly, coming from top place to bottom place in the lift is called a force. So for this, we have some directions and a magnitude, point of application of nature. See what we are doing, we are going from the directions for applying some magnitude. Magnitude is newtons. And similarly, I are applying some forces. I hope you understand what is a force. Next, for everything, there will be some specifications. For understanding what is a force, we have to know what is a force. For simple, we go with a magnitude. This magnitude represents in newtons. It's expressed in newtons. The force is expressed in a newtons called units. And every force have some directions, the line of forces. And the point of applications, the point of application at which the force is acted, the nature of the force, it indicates act upon the tensor compressors. There are many forces that I will explain you. See, if I apply a load on a brick like this, it is called compressive stress. Similarly, if I apply a load on like this, it is called tensile stress. Mainly we see the elastics. When we use the elastic, the force will be different. The force will be different. Next, specification and force is an example. See, if you see here, there is an object. We are doing a force in 10 kilonewtons. That is in the one of the magnitude. And in similar direction, we are giving the directions. Is a point of applications is here C. And similarly, when we are giving a magnitude in a particular angle at 30 degrees, and direction is here, and point of quantification is here, application is here. These are the example of force. When several forces act upon bodies, they are said to be system of forces. System of forces is several forces act upon one place is called system of forces. Like coplanar place systems and non-coplanar systems. Coplanar means the force are acting in only one plane. It is called coplanar. If the force are acting in different planes, it is called, these are the different planes, plane 1, plane 2, plane 3. Then it is called non-coplanar force. See, the non-coplanar systems, if the line of action of all the forces of the system lies on the same plane, they are said to be coplanar systems. If you see the example here, coplanar, like this, concurrent forces, parallel forces, and non-concurrent forces, and non-collinear forces. These are the example of coplanars. These are the example of coplanars. Next, non-coplanar. Non-coplanar, see, the line of action of the forces system does not lie on the same plane are referred as non-coplanar systems. See these examples of non-coplanars. There are different planes. In different planes, there are different directions. This is one direction and this is another direction in different planes. Both are parallel planes, and these are the concurrent forces. All the forces act upon one place. This is called concurrent forces. Similarly, collinear forces, plane 1 and plane 2. This is collinear forces. Next, depending upon line of action of systems, forces are further classified as concurrent forces. Line of action of force intersect at one point. See the concurrent forces, concurrent forces. And next is collinear forces. These are the collinear forces. In one point, it is defined as collinear forces. Composite of forces. The replacement two or more forces by a single force having the same effect is called composite forces. This force is also known as resultant. See, I apply a load here. This is force 1 and force 2. Due to this hinge movement, the load is act upon the one side. This is called resultant. The replacement of two or more forces by a single force having the same effect of composition, this is called single force or resultant. Next, resolution of forces. So understand this diagram here. A car is moving in inclined position at an angle of theta. See, generally for every car there will be some friction force which is acted opposite to the normal force, and this is the normal force and this is a friction force. For friction force, there is also a normal reactions to this weight. To understand these forces, we have to know what is a resolution of forces. A single force replaced by two or more force having the same effect is called resolution of forces. For this car, we are having the same effects in downward directions. Similar frictional forces opposite in other directions, and weight of the body with the normal reactions is considering resolution of forces. To find all these forces, we resolve known as components. So resolution of forces is a rectangular component. A force can be replaced by two components, like in f of x directions and f of y f of x and directions and f of y. Then what is this f of x and what is f of y? For finding this resolution of force in an angle, we have to consider this two direction of forces. That means at an angle, we are unable to find out what are the forces. So helping this cos and sine theta, if I want to know the f of x by using a theta value, we use f cos theta. Similarly, if I want to know f of y force by taking the help of f force in angle of sine theta, we use this f of y. That means for horizontal component, we use cos theta. For vertical component, we use sine theta. For horizontal, generally we prefer cos theta. How? Why? See, we know the basics of the tan trigonometry. Generally we use cos theta. What is cos theta? Adjacent by hypotenuse. Adjacent by hypotenuse. What we use for cos adjacent is f of x. Of adjacent is f of x. What is hypotenuse? F. Adjacent is f of x. What is opposite? What is opposite? Hypotenuse. What is hypotenuse? F. What is opposite? So if I want to know the f of x value, we generally cross multiply f is equals to f of x into cos theta is equals to f of x by y of f of x by f. So for finding f of x, we use cos theta into f. So here is a cos theta. Similarly for sin theta. These are known as resolution of forces in rectangular component. For finding the resolution of forces in the rectangular component, we use this formula. Theta is an angle made by a force with an x-axis. If the component of f of x and f of x constitute positive, then act towards the right upward direction. So if it is positive, we use this positive direction. And if it is opposite direction, if it is in opposite direction, we consider as negative. In resolution of force of in inclined plane. See, as I explained in previous example, a car example, which is moving in one direction, having some forces, see, in this direction, having some forces in this direction, we use this relation of forces. These are the resolution of resultant of two concurrent forces.